And we should be live. Hello. If anyone's already watching, it's always nice to hear in the chat that you can hear me and see my screen. It's always good to double check. I see a few people here already. We're going to wait just 2 minutes or so before we really get going. And let me know as you're joining, where are you watching from? And if you want to answer more questions, it'd be great to know why you're interested in ML monitoring, or maybe if you've ever deployed a machine learning model before. Let me know in the chat. And I'm just going to double check our streams. All right, looks good. Someone said Toronto. Awesome. I've been there once a long time ago, but I would like to go back because I didn't really get to do anything fun. I just was working. And we'll just wait another minute or 30 seconds before we get going. And there'll just be some slides, and then we're going to do most of this kind of hands-on portion. We'll go through some code and then look at our data and model predictions in a platform. So again, for people just joining, I saw a chunk just join. Put in the chat where you're watching from, and also maybe if you've ever put a machine learning model in production. And if you want to share a story about it, that'd be great. If you've ever seen something go wrong, or you've experienced something like data drift, let me know in the chat. I think it's always fun for me to learn a little bit about the audience, but also for everyone else in the audience to kind of see who else is watching. And if you're watching on YouTube, all the links for anything to follow along, because this is a hands-on workshop, is in the description. So you can look in the description. There'll be links for a Colab notebook, as well as a Slack channel, which is a great place to join and ask questions later. All right, so I'm going to go ahead and start going through the slides. This is ML Monitoring 103, kind of part 3 of a workshop series we've been doing. It's okay if you didn't come to the other ones. They're meant to be kind of standalone. They just kind of cover different things around ML monitoring. So today we're going to be talking about ML monitoring for bias and fairness with performance tracing. What this workshop is, hopefully it's a very friendly introduction to ML monitoring for bias. So no previous experience is really expected, but knowing some Python and machine learning concepts will be helpful because we're going to actually go through code, train a model, and then look at some outputs. So we'll cover some recap, high-level concepts in some slides, so this won't take too long. We're just going to go through some slides real quick, and then we'll go in and do the hands-on part by implementing our ML monitoring solution. Just keep in mind, you can't learn everything in the 30 or so minutes that we're going to go through this workshop with. So, you know, we're going to cover some high-level concepts and then a solution, but we won't be able to cover everything, especially when it comes to like pre-production evaluation. So depending on your experience, this can feel fast-paced or challenging. That's totally okay. Just stick through and you'll probably learn a lot. And then obviously keep learning after the workshop. So a quick introduction. My name is Sage Gillette. I'm a machine learning and MLOps evangelist at YLabs. We build really cool tools around ML observability. We're going to be looking at a couple of them today. We went previously in some other workshops more into our open source library. Today we're going to be looking at our platform where you can send data profiles to and do things like performance tracing, which we'll see today, to monitor for bias. For the past decade or over a decade now, I've worked as a software engineer or hardware engineer or doing machine learning, mostly with startups and some agencies around Seattle and also Central Florida. And I love making things with technologies in general. I always have a ton of side projects going on, and I like doing stuff with hardware and like hobby robotics stuff. So a little bit about you. I saw, one person so far said where they're watching from. At the bare minimum, it'd be great if you want to post in the chat where are you watching from, why are you interested in ML monitoring. Maybe if you've ever put a model in production before, introduce yourself in the chat. And then also if you want to stay connected, again, the link is in the description on YouTube, but I'll post it in the chat here, and I'll post it in the LinkedIn stream as well. There's a Slack channel. It's a good place to join and ask questions about anything we're going to cover today, but also stay connected with other industry professionals. Someone said they're watching from Pittsburgh. Welcome. I have not been to Pittsburgh yet, but I would like to visit. Quick setup for today. We're going to be using something called Google Colab Notebook, so you need a Google account for that. I'm assuming most people already have a Google account. The other account you'll want to create should be very quick. It's a YLabs free account. Again, I'll post the link in the chat, but the link should be in the description as well. And it should just ask for you to verify your email, and then you should be good to go. There's no card or anything required to sign up. So we're just going to be using that. And then we're going to train a model of scikit-learn. And we're going to use the open source YLogs library I briefly mentioned, and then the YLabs platform today. So a quick recap, what is ML monitoring? It's the collection of different metrics in your pipeline. We'll see a graph of it in the next slide, or a high-level concept of it. But and we've covered most of these more in depth in the previous workshops, so we're not going to spend a ton of time on them today. We're going to get pretty quickly to the hands-on part. But just to recap, we like to monitor multiple areas in our pipeline, like our model inputs, the data coming into our model to make predictions, our model outputs. You can measure for concept drift, the inputs you can measure for like data quality, data drift, and then model performance. So like the metrics you've probably used before, accuracy and recall, bias and fairness, some explainability, which we're going to cover in the next workshop, and then obviously the business KPIs. So at a high level, a system for monitoring that can look something like this. You have your pipeline, your deployed models, your training workflow. You're going to collect different statistics or data around everything in there. You're going to aggregate that telemetry and store it in ways that you can either, detect anomalies, trigger alerts, trigger automated workflows, maybe query and investigate your data more. And then with that, you can build your reports and dashboards, have those alerts and notifications, and trigger those workflows. So bias and fairness in ML. Who's seen any interesting stories around bias and fairness in ML? You've probably seen a lot of stuff like headlines in the news, pretty common ones that I've seen the last several years, like credit scoring is a big one that keeps coming up. I've anonymized the companies in these headlines, but credit card and investigated after gender discrimination complaints. There was a story a couple of years ago where credit card was, proving men way higher than women, facial recognition, criminal sentencing, medical diagnosis, hiring, voice recognition. And then not all of them are this drastic. These are the ones that make the headlines, but your models can be biased towards just specific regions of your data as well, right? Like if you trained a model on some region of data and then you got a new region, like it was all northern, a plant in the north, and then your plants were in the south. Your distribution of whatever your measurements is could be off, which is what we're going to see today in the hands-on portion as well. But you've probably seen a lot of stuff around this in the news, right? And it's very important, especially depending on your application, like credit scoring and things like that, where you can't really discriminate in those use cases. So detecting bias in production, which is what we're going to focus on today. Again, this is kind of a short workshop, so we can't cover everything around measuring bias and fairness. And there's a lot you can do in the training portion, right? Like you want to make sure that the training data you're selecting doesn't have any bias in it that you can tell based on the data you have available. Today, we're going to be looking at maybe you already have a trained model, it's already in production, and you want to see how it's performing on new data coming in and seeing if it's biased in any way. So a great way to do that is with something called segmentation. And again, we'll go more into this in the hands-on part. But segments can be on features included in the training data. So this example, can't zoom in there. This example has some that's in the training data, like how is this model predicting a score based on categories of groceries, right? And it's useful to break it down to see, okay, accuracy on beverages is very low versus like eggs and meat is very high. So this is a case of segmenting on like a data that's probably in the training data, but it's very common to add a segment or a group that's not explicitly in the training data. So going back to these ones, like credit scoring, they probably don't have gender actually coded into the training data there, but there might be some features or something in there that relates to it, and then you want to go back and either add more data in that's not going to be biased or maybe do some feature engineering around those features. So today we're going to look at looking at model production and then segmenting it out and see how it's performing on specific subgroups. So enough slides. Like I said, it's going to be very quick on the slides part. We're going to go straight into the hands-on portion. So again, the link should be in the description on YouTube. I'm going to copy this in the chat though, just in case. And I'll also put it in the LinkedIn chat as well for anyone who wants to follow along. So open up this link. This is going to take you to a Google Colab notebook. So it'll look something like this. Once you're here, you want to go to File and save a copy in Drive. This will give you your own copy of this file. You can edit it. You can do whatever you want with it. You could always come back to this original link and make another copy from here. Oops. Paste that link one more time for LinkedIn. All right. Anyone who wants to follow along, were you able to make a copy? I'm going to zoom in a little bit for the stream here. Does that look good for everyone? So again, open that link, go to File, save a copy in Drive. And then the other thing you want to do while we're pausing for a minute is, if you didn't already, sign up for that account on YLabs. And that's the tool we're going to be using today to look at our data. Close this. This might not be open for you, but this is a folder preview. I'm going to close that for mine. And now I'm in my copy. Again, for anyone, I see some people just join. The link should be in the description below. We're just getting to the Google Colab part. So go ahead and open that link and go to File, save a copy in Drive. And this will save your own copy of this Jupyter notebook. So if you're not familiar with a Jupyter Notebook or Google Colab, Google Colab is essentially Google's way of hosting a Jupyter Notebook. It's a very popular tool to use as a data scientist or machine learning engineer. It allows us to write code, documentation, and see outputs all in one place. So let's go ahead and initialize our instance here. We can run this first code cell. You can press that play button, but what I often do is just hit Shift-Enter. That's going to run that code cell and then move me towards the next cell. So if there's a whole bunch of code cells in order, you can hit Shift-Enter, Shift-Enter, Shift-Enter. You can also run terminal commands, because this actually is a whole little Ubuntu instance that you get here. And you can also pip install library. So it comes pre-installed with the most common machine learning libraries like scikit-learn, TensorFlow, etc. So we're just going to install one today, which is ylogs, the open source library to create data profiles, which again, we'll talk about those more in a minute. If you were at the last workshops, we've already gone a little bit more in depth on them. So go ahead and pip install ylogs. And this should just take a few minutes. While that is installing, again, the link should be in the description, but I'll share the link to ylogs. So that's our GitHub repo for the open source project. Also, we always appreciate a GitHub star, if you're already logged in especially. All right, so this is a very important step if you're following along. Once we've reinstalled once we pip installed our library, we want to restart the runtime. Otherwise, you might get an issue later on. So if you don't restart the runtime here, you might get an error. Just calling it now, so definitely restart the runtime. Just hit yes. That's because it uninstalled a previous library and it needs to restart with that current one that we installed, which was a dependency for ylogs here. All right, so now if you copied it from the link I sent you right now, the current section that we want to work from should already be open. If you're coming back and watching the recording of this later, it's possible that I'm working on a different section and one of these is expanded. So these are the previous workshop materials. You can follow along with these later too. After this workshop, there's the recordings on the YouTube channel that you're watching this from. And you have this notebook, so you can actually go and just run all this code and it'll walk you through all the stuff we covered previously in other workshops. But make sure right now, if you're following along for 103, the monitoring for bias and fairness, to make sure this section is expanded. So let's go ahead and run the first code cell here. We're just going to be importing the libraries we're going to be using, ylogs, pandas, numpy, scikit-learn to train our model, and then we're just going to override a setting in pandas data frame so we can see a whole profile in a second. So we're going to load in the classic iris data set, but don't worry, we're going to be looking at some more interesting data sets soon. But we're going to train our model just on the data set that comes with scikit-learn. So let's quickly train our machine learning model just so we have a model to make predictions on and see how it's performing. I will go over this very quickly, but if you've ever trained a machine learning model with scikit-learn, you're probably pretty familiar with this. We're importing neighbors we're using a k-nearest neighbor model from scikit-learn. We're setting the nearest neighbors to 5, so it's going to be looking at the 5 closest data points for that new piece of data and making a prediction based on that. We're doing our train test split here, and we're saving 30% of the data for evaluation or testing. And then the stratify is just to make sure that we get as equal number of classes in our training data set as possible. Then we train it, and then we get our prediction, and then we get our score. So based on just the test data set in there, our model is 97% accurate. And here's a little chart we might come back to later when we're troubleshooting a model. Spoiler alert, it may not perform well on something. So just as an intuition reminder for k-nearest neighbors, you get a new piece of data. In this case, it's looking at the 4 closest neighbors, and then it's going to make a prediction based on that. So in this case, it would probably predict versicola. That's the closest neighbors in this plot to it. So one more little setup cell here. This looks maybe a little ugly. We're just importing a whole bunch of data because we're going to simulate running our model or having run our model for 7 days. So we just have 7 batches of data here. That's all we're doing. And then we just have this data frame list that contains all the features to make predictions. And then we have our target. We're going to build these together a little bit later so we can actually get the ground truth and then verify performance on these. So just remember, we just have a 2 data frame lists here. And if we look at what this data set looks like, we have our classic iris data set, except for with something a little bit different here. It has a state that each measurement was taken in. So this is some synthetic data here that I've made to kind of show the performance tracing in this case. So we have our sepal length, our width, our petal length and width, just like you may have seen before. And then we're going to use those to make our prediction of what class this flower belongs to. So creating a profile in ylogs, again, I won't go too in depth here. We already covered it in the previous workshops. You can go watch the first one. We cover a lot more of ylogs features. But just to recap, the profiles generated with ylogs are secure, efficient, customizable, and mergeable. And they are a profile of your data. So they don't really contain raw data from your data set. They're kind of like these fancy aggregates of it. So you can see here, we have some columns in our data frame, like cardinality estimate. So it estimated that there's 49 unique values in our petal length column for the data set that we just made a profile of. We can see, there's 150 rows. We can see some distribution metrics. We can see the mean, the median, the min, the max, all those nice numbers that we'd want from our data set. You can see this doesn't actually really contain raw data. It's just these kind of statistical values about that data set. And just with these values, you can do really cool stuff like predict data drift, like we covered before, do data quality validation, all pretty securely and very lightweight, so you're not transferring whole raw data sets around. Again, links in the notebook if you want to learn more about those things with ylogs. And there's a lot of examples included in the GitHub repo. All right, so today we're going to mainly focus on just writing these profiles up to ylabs and looking at some of the features in there for the performance tracing. Again, we had covered detecting data drift in an earlier workshop. So just one more little setup here, and then we should be good to go to run all the cells and look at our data. So we want to get 3 things from our ylabs account. So again, if you didn't, the link is in the description below to sign up. And go to your ylabs platform. Your homepage should look something like this. You might have 1 or 2 demo projects that were there by default. If you want, you can go to, you hit create project, go to setup model. This will bring you to the model editing page anyway. If you want to delete any of the existing models that are in there for you, you can just hit this edit model and dataset button and then hit delete. I'm going to leave the one I have, but you could delete any extras you have that you haven't set up yet. And then I want to create a new model. So I'm going to go ahead and name this trace March. You can name it whatever you want. And then this is important. If you don't do this a little bit later, you might get an error. Or it's okay. You can come back here and edit it. But we want to make the model type a classification model. So when we're calculating our classification performance metrics, this is the right model type for us. So hit add model or dataset, and then you can see I have this number here. My model is 131. Yours will probably be 01, a much lower number. I'm going to grab that number, and then I'm going to paste it into my model ID here. Make sure you don't accidentally copy any spaces into it. You don't want any spaces or new lines in these 3 values. I'm going to go back to the platform, in this same window, just hit access tokens. This will bring you to this token page. I'll just call this tracing March. Create a new token, hit copy right here. Again, go back to your notebook, paste that to the API key. And then just one more thing is the org ID is on the same page. You can grab it from here or here. I'll just grab it here. And I'll paste it in. And I accidentally picked up a new line. So again, just make sure there's no spaces or new lines in here. And it should look something like this for you, but with different numbers. So I'll give you all a minute to catch up and do that. Let me know if you need me to repeat and go through how to get any of those numbers again. Was anyone able to make an account, at least get started on this, getting the numbers? Again, if you want me to come back to this in a little bit, let me know as well. I'll go ahead and moving forward. Looks like someone said yes. All right. Someone said, oh, okay. Someone else said also showed the API again. Okay, yep. So once you're in here, I'll just go back to the home screen. So you're in the home screen here at YLabs. We went to create a new project, but no matter where you are in here, you can go to settings with this little hamburger menu off to the side. Go to settings, go to model and dataset management or access token. Sorry, in your case, you want to go to this access token one. Once you're in this page, you can switch between that model and dataset management tabs very easily, as well as how to set up notifications and user management is in here as well. But so for access token, just type in a name here. You can have an expiration date on that token if you want, and then hit create access token. And then you'll want to copy this token that's in that blue bar at the top. And then I'm going to go back to the notebook. Let me know, again, if you want me to go through that more. So now we have these environment variables set to write our data profiles up to YLabs. Just as a reminder, you can just write those profiles in 2 lines of code. We're going to go through, build a data frame, and then do something called backfilling. But in production, if you want to kind of send data up live, you can just do that with a couple lines of code, seen here. We have examples again on GitHub doing this in like Flask or BentoML. Probably the serving framework that you're using. So here, you can just go ahead and run this. We're just creating we're running through all those batches of data that we imported, and we're making predictions on all of them. So we're predicting just with these features, the sepal and petal length and width. That's what our model was trained on. And then we're just appending the model output to the data frame. So here we're just building data frames right now. So you can see that our data frame now has the predicted class and the predicted probability from our scikit-learn model. So now we're going to go ahead and backfill these. Go ahead and run these 2 cells. This is importing some stuff from YLogs to do segmentation. And then what we're doing here is, like I mentioned, just with those 2 lines of code, you could write up a profile. And by default, if you do that, the date and timestamp is the date and time that you write that profile. But what we want to do is take those 7 data frames and then subtract a day. So we're basically just filling in 7 days, like pretending like we are running our models for 7 days and getting those prediction results and then writing up to YLabs. You'll see in a second what that looks like. But so all we're doing is walking through each data frame here, setting the time zone based on the data frame. And then this is one thing a little bit different that we're doing today is we're segmenting out our data. So we have this segments on column feature, and then we're going to segment on state. So you can't see there's 3 states in here. There's Washington, Florida, and Missouri. We're going to take those 3 segments, and then we're going to be able to look at our data in different ways in the YLabs platform once we've done that. So before we go to YLabs, let's go ahead and just run a few more code cells, and then everything will be done in the code section, and we can spend the rest of the time in the platform there. And if you want to learn more about segmentation, we have really good documentation on that here with YLogs, and you can do things like multi-column segmentation. Here, we're just segmenting on 1 column. There's a lot of cool stuff you can do with it. And of course, you can use it just in YLogs, the open source library, and do all the stuff with profiles and stuff in your environment there as well. without sending it to Y-Labs. So real quick, we're just going to append the ground truth. So now our data frame looks like this. We have a whole bunch of information from our features, the state, the segment we're going to segment on. We have the class output, we have the probability output, and then we have the ground truth. So these are the actual labels. We can see just eyeballing it. It looks pretty good so far in these few that we can see. So we'll just import one more thing from ylogs, this log classification metrics. And then again, we're backfilling data, so it's similar to the other code cell where we're enumerating through those data frames, and then we're pushing data up for those 7 days. Except for we're using this log classification metric section, and we're passing in just ground truth, class output, and then again, segmenting on state here. So again, we'll see what this looks like in a minute. There's other resources here if you want to read, again, more about segmentation, performance tracing. There's also a link if you want to request a certificate. We're not done yet with the workshop, so don't leave. We're going to go look at this data now in the platform. So open up your ylog or ylabs tab. And then we have our model here, trace March. So let's go ahead and open that. And I'll just do a quick overview again. We went more into these features in the past workshop. But here we have our summary tab. So we can see we actually have 3 segments in our data. That's those 3 states I had mentioned. We have 5 features here. We have 7 data profiles. That's because we backfilled our data like we were talking about. If you go to the monitoring manager tab, we've covered this again before, but you can enable monitoring on your inputs or model performance very, very easily in that tab. If you go to the profiles, we can see these are all the profiles we uploaded. We can actually compare them against each other, which is kind of convenient in this window. You can see what the distribution looks like between them all. Inputs, if we open up one of these petal lengths, we can see this is kind of the distribution of our data through those past 7 days. So when we saw that profile, it had that min, the max, the quantile distributions. This is a visualization of those profiles over the last 7 days right here. And eyeballing this, we can see that the data looks pretty steady, right? If you were here at one of the last workshops, we saw that it went up or it went down. And it looked a little interesting in some places. And just eyeballing, you could probably tell that there was data drift in those cases. In this case, this looks fine at first glance. And again, spoiler alert, there might be something interesting in here that we're going to find with the performance tracing. So again, if we go to the outputs tab as well, we have our class outputs that we wrote up. We can see these were all the predicted classes for each of those days. We have the probability output. You can see most of them. You can turn off and on some of these little things as well. So we can look at this kind of top line is saying, you know, most of them fell in a range close to 100. And then we have our segments tab now. This is new. If you were here for the other workshops, we didn't have the segments because this is the first time we're using segmentation. We're going to come back to this tab in a minute when we're kind of troubleshooting what could be going on with our model. But just know we can now view everything that we just viewed, like those inputs and outputs, in a segmented format by looking at those 3 states. Let's go to the performance tab. Now, we did see something in the performance tab at the last workshop, but now that we have segments involved, this gets really neat right here. We can see our overall accuracy, recall, etc. for our model. Now we can choose a segment from this dropdown and see how that segmented performed against the overall data set. So here, we can see that Florida is kind of below the average of the rest of the data set. So let's look at these other 2 segments. Missouri, accuracy is actually higher than the overall data set. And then Washington is also a little bit higher than the data set. So there's a legend there. The orange line is Washington, or the states in this case. So just looking at that briefly tells me that, you know, our model is underperforming or not performing as well on this Florida segmented data. So let's dig a little bit deeper with this tracing tab, which is really neat. We have our 3 segments here. And by default, it comes up with the accuracy plot and the prediction count, but we can hit a secondary metric here. Let's look at false positive rate is a good one. So here, comparing kind of these results on our segments, we can see that across all of our profiles, Florida accuracy was about 80%, 81%. Missouri was 96, and Washington was almost 95. So quite a big difference depending on your application. Maybe you're okay with that, maybe you're not. In this case, right, going back to the credit card use case, you could segment by gender or race if you had that data. Again, that shouldn't be in your training data, but maybe you want to go add a segment to your data afterwards and see how it's performing on the overall class. And then so if you were looking at credit approval rates and you had two classes here, or around gender, and then seeing that, wow, like the approval rate was way less for women in that case. And that could give you a good insight of how your model is biased towards one of those classes. You can also select a comparison profile here. So this will show how that specific profile compared to, in this case, the overall data set here, or you could take, compare two specific profiles as well. So this is really good for finding kind of like a needle in a haystack about how your model's performing, being able to segment it and then see specifically over time or in individual profiles how that compares against the other segments or other profiles in your data set. And then again, you can select these different metrics here, like if you want to look at the accuracy, precision versus your false positive rate. We can see, again, if we hover over this data, it gives us all the numbers there. But our false positive rate for the Florida segment is way higher than the false positive rates for both our two other states that we measured here. Now, we might go, okay, well, why? We can go and maybe investigate a little bit more with our segmented tab here. We'll go to segments. Now let's click into Florida first. And let's click into our petal length input. All right, it looks like, again, just like we saw before, everything is kind of in a straight line. It's not like all some big sign of drift there on a specific profile or anything like that, like we've seen in the past. Let's take a quick look here at like the median, the max, the min. Those are kind of things I like to start looking at sometimes. So just by the median, you might be able to tell the distribution changed a lot from your data set. So here the median is 5.3, kind of across. Most of these profiles are 5.3-ish. Let's go ahead and from this drop down, now look at what the median is in Missouri. 4.2. So almost a whole number off, or one digit off, or one digit difference. We could look at Washington, and this distribution or median is similar to Missouri, so it's in kind of the lower 4 range, whereas the Florida was kind of in the upper range. That's pretty interesting. So to me, again, just looking at that, it tells me that the petal length was higher in this case. For the Florida segment, and we could go ahead and look at the other features if we want as well. I made the data set, so I actually know that the only big difference here is this petal length. So that petal length being like 1 digit higher at a median for all the Florida values is making the predictions less accurate. And we can actually go to this output tab as well in our after clicking on segments, and so we can actually look at the outputs from segments. So if you click on class outputs, we can see, for the state of Washington, these were all the predicted classes over each day. And we can do that for each one. This can be interesting. Like you might be able to see, well, the Florida one has way more Virginica predicted. Probably because now that we know that the petal length is higher, that might be an important feature to make that prediction. And in the next workshop, we'll actually be looking at explainability and seeing feature importance, which will be fun. But let's look at the probability output. So for Florida, again, I can see that, just based on this chart, there's kind of a bigger distribution here from like 80% confident to 90-something% confident that, it belongs to that flower. And if I look at a different state, again, you could look at these quantile metrics. So like that 20 to 75 is going to be the majority of your data. You can see that it's almost 100% sure on most of the predictions. Whereas when we looked at the Florida one, that distribution for us was way more all over the place, from below 80 to upper 90s. So that tells us, right, that this wasn't as confident on the data either as well. And that's a quick kind of use case of how we can segment our data and look at it, how it's performing on different classes, in this case segments, and detect the bias or detect potential bias in there. Does anyone have any questions? Or does anyone think that's interesting? Is that something that you are like, ah, that's super useful, that would have saved me in the past? Was there anything anyone wanted me to cover again? I'll just go back to this notebook real quick. So just wrapping up, we went through, covered, again, very quickly, high level around some bias in ML and how we could detect it. Again, there's resources. So if you want to learn more about segmenting data, go to this link here. If you want to learn more about performance tracing, go to the link there. We have that all in the docs and YLabs and YLogs. And if you want to request a certificate, the link is in the Colab notebook as well. It seemed like a few people were following along because they said yes, they were able to make an account and that they've uploaded a profile, or they were asking for the API key again. Were you able to get through to the end here and kind of see how we were able to detect, in this case, right, our bias is just in regions, kind of like we had mentioned. There's several different use cases, and in this case, our model isn't performing as well on the Florida data. And then you can fix this by potentially taking this data that you collected from production, annotating it, and then retraining our model. So in this case, we investigated it, and it looked like, just based on our quick little investigation, that the pedal length was higher in the Florida ones, and that was throwing off kind of our model prediction because it wasn't trained with that data. If we threw that new data in and correctly annotated it, then chances are our model would be performing better on this region. Someone said yes, that was interesting, and they were able to get through. Awesome. Yeah, have you had to do something like this before on a model in production? Or have you had a time where maybe a model's failed and you wanted to look at some segmented data like this? And maybe you did, maybe it just wasn't as convenient. Someone asked about other metrics besides tracking fairness, other than accuracy. In production here, and if someone has more experience in the specific fairness metrics, feel free to jump in. Oh, and they said, yes, they had to manually write code in Python. Yep, that's been, that's actually one reason I joined YLabs, is I was working on projects and kept running into things like data drift, monitoring for data drift and all this stuff that was pretty complex to set up. And I was looking at using them, and I was like, that's a really cool problem. I want to go work on it. So yeah, instead of manually writing so much Python code, we make it really easy to ingest data profiles that you can set up monitors for. In this tab, in case you didn't see, there are other scores, like besides accuracy, your F1 score, C, and your the one I like to look at in this case is also the false positive rate. And then in the next workshop, we'll also be looking at explainability, which can totally go into kind of the bias and fairness part too. So if you haven't done model explainability before, let's see if we have a graph up. You know, it's a way of kind of weighting how important your features are, and then you could see what's influenced your machine learning model the most. So again, you shouldn't have those features like hard-coded, like a specific race of a person or something like that, but you might be able to go look and see why your model is giving certain predictions with the explainability piece. Out of curiosity, what kind of model did you have in production, if you're okay sharing? You don't have to share any critical details or anything, but was it like a classification model? Was it a classification computer vision model? Was it tabular data? always fun seeing what types of models people have run. And this workshop is going to be recorded, so the same link that you're at now, you'll be able to come back to this and watch the recording if you want to come back and follow along. And all the links are in the description on YouTube as well. So I'll actually share the YouTube link in the LinkedIn chat as well, in case anyone wants to go there to kind of get all the updated links and everything. It said real-time computer vision, detection and classification on images. Awesome. Yeah, I don't think I said it in my intro. I've done a lot of stuff with computer vision. So often when I'm explaining stuff, I think about it in computer vision terms or explain it in computer vision terms as well. One cool thing that I don't think I really talked about. So, we backfill data today out of this data frame, and I mentioned how these profiles are very lightweight and mergeable. One thing I think is really cool is you can actually run ylogs on a lot of edge devices. So if you're doing computer vision or some other tabular or NLP type computation on an edge device, like a Jetson Nano or Raspberry Pi or something like that, you can actually install ylogs there, store these profiles, and because they don't contain that raw data, they're actually very lightweight. And so if you don't have a reliable internet connection or you're on the cellular internet connection, they're also lightweight to send through that. So talking about that person's computer vision case, if you've ever done computer vision stuff on the edge and you're trying to monitor your data on a different platform, it can be very costly or hard because sending images can be very expensive. If you're, your T-Mobile bill or whatever you're using could be very high, but sending these profiles are actually super efficient. So you can actually save them on your device, and then maybe you write them up once a day or something like that to YLabs or wherever you're storing them, and then you could compare for data drift or any issues there. There's also been a lot of really good books recently. I'm blanking on some of the names around responsible AI, and they go obviously way more in depth in monitoring for bias and fairness than we did today. This is more of a quick high level and how to do something practically. Does anyone remember the names of them? I think Designing Machine Learning Systems by Chip is really popular. I think there's one just called Reliable Machine Learning that is on my list. And then there's one that just came out from, actually I know one of the authors at Google. I think it's Explainable AI. It might just be the title of it. But they go really in depth about how to implement explainable AI systems for like your modern day infrastructure, which is really cool as well. Someone said they have a data set of 5 million images with 150K classes. You think we can log through your platform? I'd love to try it. The images itself is actually going to be really lightweight there. And if you want to sync up more about that project, join the Slack channel or connect with me on LinkedIn, and we should talk about it. I think that'd be cool. I'm curious about what the 150,000 classes are for. Because that's a lot of classes. But yeah, the cool thing about images, so I actually did a workshop previously. It's on the YouTube channel, actually, if you're watching, which I know you're commenting on there, so you are. If you go to YouTube channel, in the previous live streams, there's actually a workshop on monitoring computer vision models. So it talks about logging image statistics. By default, we have an image function where it'll get things like the brightness and kind of like saturation values from your images, RGB values. But ylogs is really flexible, and you can kind of log anything that you could turn in, or imagine like anything you could turn into a Python object or a data frame. You could log that. So there's some interesting stuff that you could do around like object detection, for instance, which I've done a lot with. So talking about computer vision is really fun for me. But you can measure things like box sizes or just the color of things within that specific box for object detection. So yeah, I don't think I mentioned how flexible these logs are too, which is cool. And then if you're doing stuff with like NLP, we have some examples on our GitHub around that as well, specifically around embeddings, which is exciting. Awesome. Thank you for sharing about your model and asking the great questions too. It's always fun to hear from a few people in the audience, so I really appreciate it. And yeah, hopefully you sent me a connection or you join the Slack, and then we can talk more about your use case, because I'd love to hear more about it. It sounds interesting to me. And with that, though, I think I'm going to wrap up the stream. We kind of went through the stuff that I had made for today. Again, it seems like some of you found it interesting and useful. Let me know. I'm always happy to hear if this seems like an interesting use case or something that you'd actually want to implement in a model today, whether that's for a personal project, a school project, or actually something in production. Let me know, and hopefully we'll stay connected, and I'll talk to some of you all later. But with that, I'm going to wrap up the stream. So everyone have a great day. And again, hopefully I'll talk to some of you later and hear more about the cool projects you're working on. All right, goodbye, everyone.